Most people think they are thinking, but they are often guessing. Richard Feynman built his life around doing real thinking on purpose. You begin to notice how guessing happens. A quick answer appears in your mind. It feels right. It feels familiar. You accept it and move on. This is not deep thinking. It is a fast reaction. Habit often replaces reasoning. Feynman explained that the brain likes shortcuts. Shortcuts save time, but they also create errors. They create confidence without proof. When you rely on quick answers, you may miss what matters. You may ignore details. You may stop checking. Psychology explains this with cognitive shortcuts and bias. The mind uses simple rules to decide fast. These rules can help, but they can also mislead. Thinking must be done on purpose. Scientific thinking means you follow evidence, not comfort. Feynman explained that a scientist does not protect an idea. A scientist tests an idea. If the test fails, the idea must change. This is the heart of scientific thinking. It is not about being clever. It is about being correct. You begin to see what this requires. You state a claim in clear words. You ask what facts support it. You ask what facts would disprove it. You check results, not feelings. You also accept being wrong as part of the process. Scientific reasoning works this way. It demands clear steps and clear tests. It also demands honesty about limits. If you do not know, you say so. If you are guessing, you label it as a guess. Feynman respected this style because it protects you from self-deception. It keeps you close to reality. It turns thinking into a method, not a mood. Scientific thinking follows evidence, not comfort. Clear questions guide clear thinking. You begin to notice that many problems stay unsolved because they are framed poorly. The question is vague. The goal is unclear. The terms are mixed. Then the answer becomes messy. Feynman started by defining the problem. He would ask what is known, what is unknown, and what needs to be explained. He would reduce the question to a simple form. This prevents wasted work. If you do not know what you are trying to solve, you cannot test progress. Research on problem framing supports this. The way you define a problem changes the way you search for solutions. A clear problem creates clear constraints. It also reveals what data you need. You begin to see a simple method. Write the problem in one sentence. Define the key words. State what a good answer must do. Then begin reasoning. This is not slow for no reason. It is a speed tool because it prevents wrong paths. Clear questions guide clear thinking. Big problems become solvable when you split them. You begin to see why large problems feel heavy. They contain many parts at once. Your mind tries to hold everything together. This creates confusion and missteps. Feynman broke problems into small pieces. He would isolate one part and work on it until it was clear. Then he would move to the next part. Only after that would he combine the parts again. This keeps thinking clean. It also makes errors easier to find. Reduction in scientific problem solving supports this. Complex systems often become clearer when you understand smaller parts and their links. This does not mean the whole is ignored. It means the whole becomes clear through controlled steps. You begin to see a practical approach. List the parts of the problem. Choose the smallest part you can test or explain. Solve that part. Write what you learned. Then move to the next part. Small steps can be checked, and that is why they work. Accuracy improves when you label what is real and what is guessed. You begin to notice how the mind mixes facts and beliefs. You hear a fact. You add a guess. Soon the guess feels like a fact. This is how errors grow without notice. Feynman separated what he knew from what he assumed. He would state the facts first. Then he would list assumptions clearly. He did this because assumptions can be wrong. If you hide them, you cannot fix the reasoning later. Good thinking respects limits. It does not pretend certainty where there is none. You begin to see a simple habit. When you make a claim, write 2 lines. First, the facts that support it. Second, the assumptions you are using. If an assumption changes, update the claim. This keeps thinking honest and reduces false confidence. Clear thinking starts with honest limits. Simple explanation is a thinking tool, not a style choice. Feynman explained problems in plain words to test understanding. He did not trust complex language as proof. He trusted clear meaning and clear steps. You begin to see why this works. When you explain simply, you must define terms. You must state cause and effect. You must keep the logic visible. If you cannot explain a step, you do not understand that step yet. Research on language and cognition supports this. Complex words can compress steps and hide gaps. Simple words make gaps obvious. They also make it easier to check your reasoning because each step is easier to hold in working memory. You begin to see a practical test. Try to explain the problem as if to a smart teenager. Use short sentences. Avoid jargon. If you need a technical term, define it in plain words. Then restate the full idea simply. Simple explanations keep thinking honest. An idea must face real results. Feynman explained that nature is the final judge. Your belief does not matter. Your status does not matter. If the idea does not match reality, it is wrong. You begin to see how this applies beyond science class. In daily life, you can test claims too. If you believe a method works, measure the result. If you think a change will help, predict what should happen and check what happens. If the result disagrees, update the idea. This is the core logic of testing. Make a claim. Make a prediction. Compare with evidence. If the evidence conflicts, change the claim. A useful claim must be able to fail. If no result could prove it wrong, it is not guiding you toward truth. Feynman trusted tests because tests reduce self-deception. They also turn debate into data. Reality decides what is true. The biggest danger in thinking is self-deception. Feynman warned that the easiest person to fool is yourself. The mind defends its own ideas. It prefers being right over being correct. This creates blind spots. You begin to see confirmation bias at work. You notice evidence that supports your view. You ignore evidence that does not. You explain away problems. You treat one success as proof and one failure as an exception. Research supports a simple fix. People become more accurate when they actively search for disconfirming evidence. You try to break your own idea. You look for cases where it fails. You ask what would make you change your mind. Feynman used self-checking as a rule. He attacked his own thinking first because it was safer than waiting for reality to punish the error later. You begin to see a simple discipline. Treat your favorite idea as the first suspect, then test it harder. Honest thinking begins with self-checking. Models guide thinking better than opinions. Feynman used models to explain how things work. A model has parts. A model has links. A model predicts outcomes. An opinion often has none of these. It may express a feeling, but it does not explain reality. You begin to see the difference in your own reasoning. When you have a model, you can trace cause and effect. You can predict what will happen if one part changes. You can test the prediction. Then you can update the model. This is reliable thinking. People understand systems better when they build internal models. These models reduce confusion and help you apply ideas in new problems. They also help you locate errors because the structure is visible. Feynman kept models simple. He avoided extra parts. He used only what mattered for prediction and test. That is why his thinking stayed clear under pressure. Models produce reliable thinking. Speed feels good, but it often reduces accuracy. You begin to notice that fast thinking jumps to conclusions. It skips checks. It accepts the first clean story. This can work for small tasks, but it fails when problems are complex or high. Feynman slowed down when accuracy mattered. He checked steps. He checked units. He checked assumptions. He compared results with reality. He did not rush to finish. He rushed to be correct. Research on thinking supports this. The mind has a fast mode and a slow mode. Fast mode is automatic and quick. Slow mode is deliberate and careful. Scientific thinking uses the slow mode when it matters. You begin to see a simple rule. When the cost of error is high, slow down. Write the steps. Verify each step. Look for alternative explanations. Check the result with a basic sanity test. Careful thought is a form of respect for truth. Slow thinking improves results. Scientific thinking becomes strong when it becomes routine. Feynman used simple habits every day. He framed problems clearly. He broke them into parts. He labeled facts and assumptions. He explained ideas in plain words. He tested against reality. He watched for self-deception. He relied on models. He slowed down when accuracy mattered. You begin to see that none of this is magic. It is a system. It works because it is repeated. The more you practice it, the faster it becomes. Over time, you react less and reason more. You guess less and test more. The brain changes with repeated practice. Skills become smoother and more automatic. The method becomes your default. Feynman's message was simple. Do not pretend to know. Build knowledge through tests and clear steps. Clear thinking grows through daily practice.